Hey guys, in this video we're going to be covering target 2D.2, and our mastery learning objective is I can identify the vertex of a quadratic equation by completing the square. Alright, so a quick recap. Remember when we had in function notation f of x equals the quantity of x minus 4 squared plus 1, and then we asked you to find the vertex. The only thing that changes was that x value. So remember, right? Only value that changes, only change the sign of the x. Right? So if it was a positive, we flipped that to be, or if it was a negative, we flipped it to be a positive. Right? And then we kept the y value, so whatever was adding or subtracting, as the y value of the vertex. Alright, and then we had to graph what that looked like. Well, the vertex was 4, 1, so I go over 4 up 1. That is my point right there. And then I noticed that it was a positive, right? There's no subtraction sign here, so if it's a plus sign, that means our parabola is opening upward, and it's going to look like that U shape, right? So if it is a positive, it's going to be opening upward. So from that vertex point, just going to rough sketch a graph and make sure you extend those arrows and those lines all the way up as possible. Right, so that's what we're going to try to get to. But before we get there, we have to kind of put things in vertex form by completing the square. So let's go ahead and look at the first example. All the steps for these examples are written out on that right side. So in case you ever get stuck, please just reference those sides to help you kind of work through these problems. The first step is set the quadratic function equal to 0. Looks like a typo right there. So step 1, set the equation equal to 0. So what I'm going to do is I'm going to bring my function down. X squared minus 2x minus 5 is going to equal 0. Alright, next step says, step 2, move the constant to the other side. So remember, the constant is something with no variable, right? No variable. There's no letter attached to it. It is just the number. So a constant in this case is going to be that 5. And the way I move it over, if I'm subtracting, I do the opposite, right? The inverse operation. And whatever I do to one side, I have to do to the other side. Alright, so what that gives me on the left side is x squared minus 2x equals, I'm going to leave a space there, 0 plus 5 is 5. Alright, next step says identify the number that would complete the square and add it to both sides. I'm going to do a Punnett square box then. Alright, that first term, x squared, I'm going to put in the top left corner. That middle term, I have to divide it in half. So what I'm going to do is I'm going to take that negative 2x, and I have to divide it by how many boxes it's going in between. So negative 2x divided by 2 is a negative 1x. So that negative 1x is what I'm going to put in that top and bottom corner. So this is going to be negative 1x, negative 1x. And then I figure out what the outside of my parabola is going to be. So I have an x times an x times a negative 1, x times a negative 1, which means my final box then, negative 1 times a negative 1, is a positive 1. That is the number that I need to add on both sides. So I have to make sure I add it to the left, and I have to add it to the right. Right? This number has to get added on both sides. So when it says add to both sides, that's what I'm talking about. Okay, so following step, moving on along. I have x squared minus 2x plus 1 is going to equal 5 plus 1, which is 6. Right? Step 4, remove the perfect square trinomial as x plus or minus a squared. So that is just taking whatever we had on each side of our Punnett square, x minus 1, x minus 1, and rewriting it. Right? There was 2 of them. It was a square. They had the same side. So I'm just writing x minus 1 squared equals 6. Alright, next step says set the equation equal to 0 again. So that 6 has to move over to the other side. So I'm going to subtract 6 on both sides. My final equation then is going to look like the quantity of x minus 1 squared minus 6 equal to 0. Final step then says, well, use vertex form to find what the vertex is. So my vertex, remember it's a coordinate, it's a point. So I take the opposite, that's a positive one, or that's a negative one, so the opposite is a positive one. And I keep the y value the same at a negative 6. So that is my point. Doesn't ask us to graph it, but it was a positive value, so it would be opening upward. Alright, let's look at the next example. Alright, next example, we have f of x equaling x squared plus 14x plus 59. The first thing is set the thing equal to 0. So x squared plus 14x plus 59 is going to equal 0. Next step is move that constant over to the right side. So minus 59 minus 59. X squared plus 14x. I'm going to leave a space there because eventually we will complete the square. Minus 59. Alright, I have to complete the square now. So I'm going to draw that up here. I'm going to take my x squared. And I see that middle term right there, that 14x. So that's the number I have to divide between those two boxes. So 14x divided by 2 is going to be a 7x. And that number is what I'm going to place both in each diagonal of my funding square box. Remember, we're completing the square, so each side should be the same. So x times x times a positive 7, x times a positive 7, and 7 times 7 is 49. Alright, that's the number I am going to add on each side. You can't forget to add it to the other side, right? That's really important to remember that you have to add that number on each side. Alright, final step, we're going to simplify this. So x squared plus 14x plus 49 is going to equal negative 59 plus 49 is a negative 10. I'm going to factor, write those sides of my binomials. Remember, it was a perfect square. So I'm just going to write x plus 7. How many were there? 2. Still set equal to negative 10. I want to put this in vertex form. So let me just rewrite that. Vertex form has that equal to a 0. So I have to do the opposite and bring that 10 back over to the left side. So x plus 7 quantity squared plus 10 equals 0. State my vertex point. Always take the opposite of that x value, so that would be a negative 7. Keep that y value the same, so 10. So my vertex point is negative 7, 10. Alright, next example, moving on down. Again, if I'm moving too fast, please stop, rewind, do whatever you have to do. Alright, next activity, or next example, my apologies. Set it equal to 0. So x squared minus 12x plus 46 equal to 0. I want to get that constant over to the other side, so I'm going to subtract 46 because that is the opposite operation. Squared. Minus 12x. I'm going to leave a space. Minus 46. I'm going to complete my square now because I want to figure out what number I'm going to add on both sides. Alright? So, bring over my x squared. That middle term there is a negative 12x. I want to divide that in between two boxes. So that's going to give me a negative 6x. So negative 6x, negative 6x. Go ahead and figure out what the outside of the square is. So this would be x times a negative 6, x times a negative 6. And negative 6 times negative 6 is a positive 36. So that number, again, is what we have to add on each side. So this should be a positive 36, a positive 36, and then I'm going to simplify. So x squared minus 12x plus 36 equals negative 46 plus 36, be negative 10. I'm going to change this into factor form using that perfect square binomials that I have here. Right, so x minus 6 quantity squared, because there were 2 of them, still equal to negative 10. I want this equal to a 0, so I am going to move that 10 over by doing the opposite operation, right? I have to add 10. So my answer then is going to look like x minus 6 squared plus 10 equals 0. I'm going to state my vertex. Take the opposite of that x value. So if it is a negative, you take the opposite, which is a positive. And that y value is going to stay the same. Alright, last example here. Same steps as before. Set the quadratic equation equal to 0. So x squared plus 6x minus 5 equals 0. We want to move that constant over, following those same steps which are written alongside that first example we did. X squared plus 6x. I'm going to have a blank there. 5 plus whatever blank there that comes from my Punnett square box. I'll draw my Punnett square over here. X squared. I have that positive 6x that I want to divide in between our two diagonal boxes, which is going to equal 3x. So I'm placing those in each diagonal. And I want to then multiply, figure out what I multiplied on the side. So x times x is x squared, x times a positive 3 is a positive 3x, x times a positive 3 is a positive 3x, and my last coefficient then is 3 times 3, which is a positive 9. I'm going to go ahead and add that term to each side. So plus 9, plus 9. Alright, simplify. X squared plus 6x plus 9 is going to equal 5 plus 9, which is 14. I'm going to write the sides of my binomials. Again, you see those double x plus 3 on each side. So I'm going to write this as x plus 3 quantity squared, still equal to 14. I need to move that 14 over though, so I do the opposite operation. So subtract 14 on both sides. Ignore that, we don't need to see that yet. So my final answer then is going to be x plus 3 quantity squared minus that 14 over, now it's equal to 0. I'm going to state my vertex. I take the opposite of this, which would be a negative 3, and I keep that one the same, which is a positive 14. Alright, that brings us to the end of Target 2D.2. Go ahead and work on that activity. Good luck.